I've been experimenting with posting math-related animations on Instagram Reels and TikTok over the past year and a half on a variety of different topics. Most of these animations I do with Python and GLSL, and occasionally some parts in Blender or CapCut. But a lot of time also goes into figuring out how to break down a fresh topic that I've usually just learned about, like Lorentz transformations or UV unwrapping, into a fun, bite-sized animation with a little storyline, and oftentimes with a new spin on it, like what would a giant TV look like if it was traveling near light speed? Or how did the Laplacian eigenfunctions of a Pokemon look like? What's kind of funny is, if you add up the total amount of content that I've actually posted on either of these platforms, it's hardly 5 minutes, but somehow these videos alone made my Instagram account get enough of a following for me to get invited to 2 of Instagram's creator events last year at Meta HQ, which had exclusive interviews of Simu Liu and the CEO of Instagram, Adam Mosseri himself. So in this video, I thought I'd give the sort of random way I stumbled here and take a closer look at this notorious curvature of space / portals animation that went absolutely insane on both platforms. So without any further ado, let's get into the video. So I wasn't super into the whole TikTok stuff at first during COVID because I thought it was mostly just a brain rot dancing app or something for Jacob Sartorius. But somehow this app just kind of skyrocketed in popularity, and now you have like everything from an actual theoretical physicist explaining the Gauss-Kodazzi equations to this awesome guy that uses Desmos to create all sorts of cool animations. Yeah, weirdly enough, turns out there's actually a vibrant educational community on there. And there was this one weird trend in particular that caught my attention that even a lot of math people didn't know about. I made a post about it in the 3Blue1Brown subreddit to see if anyone else knew about it, and they largely didn't, and probably still don't because of how niche it was to TikTok. But this trend was people using his fantastic animation library called Manim, which he normally uses to make these really calm, mesmerizing math videos to beautiful piano and stuff, to instead make these really gangster, hype math edits.
Keep up, motherfuckers.
And what would typically happen is they'd sync up the main beat drop with some key part of the proof, and it was weirdly entertaining. Okay, maybe some of it was a bit over the top, but I really did like the overarching idea of animating math synced up to music, so I decided to join in on the trend and do some math animation. Now, I've always been a stickler for doing things from scratch, and during the pandemic, I'd already given a try at writing my own bare minimum knockoff of Manim. Now, any old geezer can use Tinker or Pygame to put shapes on the screen, but the coolest part of Manim to me was how smoothly everything draws on the screen like a pencil on paper, and of course, the morph. Yeah. So I sat down, and after about 2,000 lines of code that started to feel more like a Python Data Structures 101 exam, I was able to squeeze some cool animations out, like this bouncing DVD logo, and this deterministic finite automaton. Every shape it drew, like a circle or rectangle or more complex stuff, even 3D shapes, they were all some sort of parametric curve, an equation that unwinds the shape based on an input percentage value t from 0 to 1. And to get the morph, I just multiplied the target shapes equation by a different percentage value alpha, and the first ones by 1 minus alpha, and added them together. But there's a very important additional element that brings an S-tier animation to an S++ tier. You see, our brains really like to see stuff moving as it does in the real world, with things gradually changing speed, rather than abruptly. And that's where ease functions come in, like this one, that eats some input parameter value and smooths it out at the beginning and end. And bam! Look at that. Now, all of this was really cool, but honestly, the whole code just kind of became a nightmare to use. The main problem with my whole setup was that animating things was just really clunky. For some reason, I made it so that each animation is like this ugly tree of component animations where each node plays after its parent, and so to play the whole thing, you basically had to run depth first search. And then there was this whole scheme of a priority queue for maintaining all the currently playing animations or something, I don't know. It was just a complete mess, and every time I had a new idea, I just had to spend so much time re-engineering everything to support it. So I just ended up throwing it in the trash where it belonged and moved on to bigger and better things. Like my other side project at the time, which was this Doofenshmirtz Twitter bot. Anyways, fast forward a few years later, and it was TikTok that inspired me to make animations again when this trend came along. And there was this mathematical proof without words that I found in this book called, well, Proof Without Words, that I thought was kind of begging to be animated. So I whipped up PyCharm again to animate like the old days, but I only took the bare minimum I needed from the old code, like some parametric equations and ease functions, and this time I would start each animation in a mostly fresh new file. It was so much easier, and bam! Let's go! Bring it on, Charlie D'Amelio, Zach King. There's a new viral TikToker in town making banger videos about barocentric coordinates, bro, and parabolas. And this water wheel. Water wheel? Okay, so technically my math TikTok debut started a little before the whole music synced animation trend with this water wheel video that I'd made for Wikipedia, which I added that annoying TikTok voice to, and it became my first video to really blow up.
The butterfly effect.
It's this cool dynamical system from chaos theory that Steven Strogatz has a really great lecture on if you want the full details, but in short, what's cool here is that it's kind of impossible to predict what direction this wheel will be spinning over time because of how sensitive it is to the initial conditions. But the story goes that the spectators at MIT of a mechanical version of this wheel used to place bets on it anyway. And what's happening here is that there's a faucet that's filling up the topmost cup with water, and the cups are also leaky, and the wheel has friction, all of which causes the center of mass of the water in the system to draw out this really cool curve called a Lorentz attractor, which has these two empty spots which kind of look like eyes. And it's even cooler looking in 3D if you use an additional axis to represent the rotational speed of the wheel. What I think made this early video do well, besides the interesting simulations themselves, was that it was one continuous shot for the most part, which became a guiding principle for all of my later videos, including the initial music synced animations, like this 4D cube one that slowly increases in dimension aligned with the music, and this simple animation of a single parabola when viewed under 3D perspective. That one went especially insane. It was honestly lots of fun making these little videos, and I couldn't believe there was actually an audience for this stuff. Hey, who's that guy? Now, let's turn our focus to the one music synced animation that would come to rule them all. The one that actually got the approval of Michael Vsauce Stevens himself. Behold. I actually made it for this one class called Advanced Geometric Methods, and to be honest, this one I kind of just threw it on my Instagram and TikTok without putting in much thought, and just added this kind of cryptic looking text that fit the vibe of the one song that I'd picked for it. And when I woke up the next day, it was already at 1 million views on both platforms, with a bunch of nerds fighting each other in the comments about I don't even know what. Me when I bend 3-dimensional space across a 4-dimensional plane. I hope you become homeless. I used the same base code to better animate this follow-up about a month later, where I synced it up to this perfect sound I found for it, which some people did specifically enjoy, and it got similar engagement. The basic idea behind these animations is how the geometry that we're all used to, like where angles in a triangle add up to 180 and pi is approximately 3.14, fundamentally changes when the space itself in which you're doing the geometry is not the usual Euclidean one. This has very much to do with Einstein's theory of general relativity, where objects appear to travel on curved paths, which can actually be understood as not curved straight lines in a geometry that's curved. Now imagine that you're inside this weird 2D space in which if you move upward like this, and then to the left, and then down again like so, you somehow return to the same spot, albeit with a 90-degree rotation. Pretty strange, until we consider this sort of other point of view where we actually get to see how the flatland space we were operating in this whole time might look like from an outsider's perspective. An outsider that doesn't live inside this space and thus can view it as a sort of fabric of its own, which necessarily requires this portal in order to explain the premature return to the starting spot. And now looking at this full path our flatlander has traced out, we notice that it only has 3 vertices and 3 edges. So it's necessarily a triangle, all of whose interior angles are 90 degrees, adding up to a total of 270. This edge going through the portal is not actually broken up, it just appears that way from the arbitrary way that we've chosen to represent the space, in a way that makes better sense to the outsider. Now, how about we go ahead and actually identify the 2 portals to seal them shut, but to do this in a way that doesn't cause any stretching or squeezing of the space, we need an extra dimension. And bam, this has always been the geometry of a cone. What's even awesomer is, for a thinner cone, the flat, portal-like representation of the space is less fanned out in comparison. So a single straight line drawn in this geometry can have many different broken up segments, but of course if you fold it together again, we can see that it's one continuous straight line path.
That is not straight.
Okay, yeah, it's a bit counterintuitive, but this path really is a straight line with respect to the cone's geometry, because if you imagine driving a car along this path, you wouldn't have to turn the steering wheel at all to stay on track. It's exactly like the equator on a sphere, where you also wouldn't need to turn the wheel at all to follow the path, Meanwhile, to follow any other latitude line, the wheel must constantly be turned at an angle, implying that the line is curved in the sphere's geometry. See? Looks like he gets it. If I had to pick the most important thing I gained from making these videos, it's a deep appreciation for the amount of work that goes into crafting any sort of animation, whether it's computer animated, hand-drawn, or any other sort, where you constantly have to make tons of small decisions on how everything should precisely move in order to convey a particular emotion. I wanted to share a bit more details on my animation setup and various programming, animation, and storytelling tricks in this video, like how I actually programmed the 2D to 3D cone unfolding animation, or how to do more complex graphics programming in Python. But as a brain-rotted TikToker and Instagram Reels-er, editing long videos like this makes my brain go gulu gulu. So it'll have to wait for future videos. Besides Reels, I'm constantly working on other random projects too, like black hole rendering to 3D printing or neural nets and simulation blah blah blah, and that Doofenshmirtz Twitter bot which needs an upgrade, all of which will make for some cool YouTube content in the future as well. So if any of that sounds interesting, I hope you stay tuned and consider a follow on the Zuckerberg app and say hi. I'd like to chat all the time with a bunch of you awesome internet people.